The power of enums, section 4. In this section we're going to learn what exactly enums are and why they are so useful, especially in Swift. We're also going to explore the unique feature set around enums, helpful protocols that are provided and that even further enhance the capability of enums, and how to handle future values with enums in Swift 5.
Why enums are helpful.
Why are enums so powerful? Well, historically, enums were used to give names to a group of integer values. For example, 0 was error, 1 was loading, or 2 was complete. Instead of using simply a raw integer, a name corresponding to the integer dramatically enhances the readability for the programmer, and hence it diminishes errors. If we were to describe a poker hand and the cards of a player as integers, well, for a 6 and a 7, that might work okay. An 11 and a 14, it's already a little bit tricky to read. But if we pass a 1 and an 8, it's already kind of a mess. Like, is a 1 an ace, or what exactly is the value 1 representing? And obviously we can pass completely false values like 0 or -10 that are not represented in a poker cards. In Swift, enums are also types, hence they guarantee type safety. They further eliminate the chance of invalid inputs from the programmer side, and they can also be still represented by a raw value, for example by an integer or by a string, but they don't have to. I would say, let's get to it. As always, I've fired up a playground, and in this playground we're going to have a look at how easy it is to use enums in Swift. Consider the poker card example that we just looked at earlier. Now with an enum, I could simply define a enum called rank that I'm going to copy over now. And in this rank enum, we define all the cases a card in poker could have, like the 2, the 3, the 4, and so on, up until the ace. Now our poker hand would look a little bit different than on the slides. It would look like this. It would be a struct poker hand with an array of cards where each card is represented as a rank. Now, if we look at the example from the slides again, there is no more possibility for passing invalid values. The 6 and the 7 would be represented like this. The jack and the ace would be readable, and it wouldn't be like an 11 and a 14 that was already kind of a mess in the previous example. And it doesn't matter if the ace is passed as a 14 or a 1, it's always just simply an ace. And the logic behind the rank could be implemented in the future, would then determine if it's the value of 1 or 14. And incorrect values would not be possible at all. However, in Swift, it's possible to further enhance our model of a card by introducing a struct called card. Now we can also move our rank enum into this card struct and make it a kind of inner type enum. Now usually in poker, a card does not only consist of a rank, but also of a suit. And don't worry about those compiler errors, by the way. We'll fix them in just a second. So let's introduce the suit, which is either heart, diamond, club, or spades. And our card struct will get member variables for a rank and suit. Now this is a real model of a poker card where all the necessary characteristics of the card are modeled. So our card array here in the poker hand will also no longer be simply a rank, but it will be of type card. And now let's look at creating the poker hand of the 6 and the 7. It's still very easy to create the hand, simply by calling the initializer, passing the rank of 6, and let's say it was a 6 of hearts all along. And let's add the second card to our poker hand, which was a 7 of club. Now if you have wondered, the dot syntax in Swift can always be used when Swift already knows which type is used in this case. It's a suit enum, so it's a very nice and compact way and also a readable way of defining the value that's passed here. Now, that is all in this example. This was the first video about the power of enums.